If f of 2 equals negative 3, write an ordered pair that must be on the graph of y equals f of the quantity x plus 4 plus 2. So if we're given f of 2 equals negative 3, that means when the input is 2, the output is negative 3, or when x equals 2, y equals negative 3, which means this point here with coordinates 2, negative 3 would be on the basic function f of x. So now, based upon this function notation, we should be able to recognize the translations and then translate this given point. So for review, if we begin with the basic function f of x and both c and d are positive, y equals f of x plus d would shift f of x up d units because we're adding d to the function values or y values of the basic function f. And therefore y equals f of x minus d would shift f of x down d units. But if we have y equals f of the quantity x plus c, notice how this plus c would affect the inputs into function f, and because we're adding c, we actually have to use smaller values of x to get the same inputs as the basic function f of x. So because we'd have to use smaller values of x, f of the quantity x plus c would actually shift f of x left c units. And if we had y equals f of the quantity x minus c, notice here we're subtracting c from x, therefore we need larger values of x to have the same inputs as the basic function f of x. So by subtracting c here, the graph of f of x is actually shifted right c units. So by recognizing this notation, if we begin with f of the quantity x plus 4, this plus 4 here means we'd have to use smaller values of x to get the same inputs as the basic function f of x. So by adding 4 here, it would actually shift the point left 4 units. Notice when x is negative 2 here, the input would be negative 2 plus 4 or positive 2, the same input as the basic function f of x. And then this plus 2 on the end, we would be adding 2 to these function values or y values, which would actually shift the graph up 2 units. So we went left 4 and up 2, giving us the point that must be on y equals f of the quantity x plus 4 plus 2. Notice how the coordinates are negative 2, comma, negative 1. Let's also look at this another way though. If we know f of 2 equals negative 3, and we have this new function y equals f of the quantity x plus 4 plus 2, if we wanted the input of this function here to be positive 2, because we know when the input is positive 2, the output is negative 3, notice how x would have to be negative 2 to have an input of positive 2. Again, if x equals negative 2, we would have y equals f of the quantity negative 2 plus 4, and then plus 2. If we simplify again, notice how we have f of, this would be positive 2 plus 2. So by adding 4 here, we had to use an x value or an input that was 4 less than positive 2, which shifted the point left 4 units. And we know f of 2 equals negative 3, so this leaves us with y equals negative 3 plus 2. So notice how this plus 2 adds 2 to the y coordinate of the original point, shifting the point up 2 units. And negative 3 plus 2 is negative 1. So if x is negative 2, then y must be negative 1. So whichever way we look at it, the point negative 2 comma negative 1 must be on the function y equals f of the quantity x plus 4 plus 2.